For this quiz, you will see how to do a two-sample z-test using Microsoft Excel. So when do you perform the two-sample z-test? That is when we have two independent samples and we know the true standard deviations, sigma 1 and sigma 2, respectively, for the two populations from where we collected our two samples. Okay, let's go to Microsoft Excel. Here's an example where we can do a two-sample z-test. This example is about drying time of paint. I think we discussed this question also in class. There are two primer paints. Formulation 1 and formulation 2 are those two types of paints. Formulation 1 has a new drying agent. Test if there is a reduction of true mean drying time. Given that the true standard deviations for both formulation 1 and formulation 2 are equal to 8. That means sigma 1 equals 8 and sigma 2 is also equal to 8. Note that the two sets of data are independent. We need to write down the null and the alternative hypothesis. We let mu1 and mu2 with the true mean drying times of formulations 1 and 2 respectively. And then my null hypothesis should be mu1 equals mu2. So how do you write the alternative? The new drying agent can be found in formulation 1. So if it reduces the drying time, mu1 should be smaller compared to mu2. Therefore, we write down the alternative hypothesis as mu1 is lesser than mu2. That means this is a left-sided alternative. The test name. The test name is a two-sample z-test because we have two independent samples. They are given as independent and with known standard deviations. Sigma 1 equals 8, sigma 2 equals 8. Therefore, we do two-sample z-test. Okay, let's see how to perform the two-sample z-test using Microsoft Excel. For the two-sample z-test also, you will need the data analysis toolpack. In case if you haven't imported the data analysis toolpack, please go back and watch. There's a separate video explaining how to import the data analysis toolpack. So let's see how to do the two-sample z-test. You have to go to data, select the data tab, and then select the data analysis toolpack from here. And then you scroll down. And then the last one, z-test two-sample for means. Select that, z-test two-sample for means, and then click on OK. Variable 1 range, click on this little arrow. You may include the variable label, and with that, I need to select the complete set of data points under that variable. So I will press Shift, Control, and down arrow key, all three keys at once. That selected the complete set of data for the first variable. Hit Enter, and then variable 2 range. Click on this little arrow, select the variable label. With that, Shift, Control, down arrow key, we'll select the entire set of data under the second variable. Hit Enter. Hypothesized mean difference. We know that the null hypothesis is mu1 equals mu2. In case if we see it as mu1 minus mu2, if mu1 is equal to mu2, then mu1 minus mu2 should be equal to 0. So mu1 minus mu2 is called the hypothesized mean difference. So that one for this example is equal to 0. Sometimes we have to compare two means against a non-zero value as well. But for this example, I just have 0 as the hypothesized mean difference. Variable 1 variance, that should be known. And variable 2 variance, that should also be known. We have to enter those variances for these two fields. So what's the variable 1 variance? It was given in the question that the standard deviations for both variables are going to be equal to 8. So if the standard deviation is equal to 8, what should be the variance? Variance should be 8 squared, which is 64. So I will enter 64 as the variance for the first variable. How about the second variable variance? The second variable also had a standard deviation of 8, which means that should also have a variance of 8 squared, which is 64. When I selected the dataset, I included labels. Therefore, I must check this box, labels. Alpha, which is the type 1 error level, it is always equal to 5% in our class. And that is also the default value given by Microsoft Excel. So select 0.05. output range, I would like to have the output on this spreadsheet itself. Therefore, I will check this little circle, click on this little arrow, and select a cell outside of the data range. And that's it. I will hit enter. And there's nothing more to be entered. So I will simply click on OK. So here's the output for the two-sample z-test. The first line shows the mean. And we have two variables, and they have calculated means for each of those two variables. And the variances, they are the values that we entered, 64 each. Observations, we have 10 observations in each. Of course, for two independent sample comparisons, we don't necessarily need the number of observations to be the same. But for this specific example, they have 10 observations in each. Hypothesized mean difference was entered as 0. And in the next line, we have the important statistics. The z-test statistic is equal to negative 3.66. So what does that mean? For the test statistic and critical value approach, we will also need the critical value. And we are going to find the rejection region based on that critical value. And then we see if the test statistic is going to land on the rejection region. If it does, we reject our null hypothesis. So our test statistic is equal to negative 3.66. What's the critical value? Well, of course, this is a left-sided alternative. We know the critical value in one-tail tests should be 1.645. But even if you cannot remember, MS Excel will help you. It will report both one-tail critical value and also the two-tail critical value. But remember, MS Excel will only report positive critical values. So if you are testing a left-sided alternative or a two-sided alternative, make sure to read those critical values with necessary plus or minus signs. Now, this is a left-sided test. That means I need a negative critical value. So which one is the correct critical value that I should read? Is it z critical value one tail or z critical value two tail? I need to pick z critical value one tail because my alternative is a left-sided test. It is not a two-sided test. Therefore, I select z critical value one tail, which is equal to 1.645 approximately. But again, MS Excel will only report positive critical values. But our alternative is left-sided. That means our critical value should be negative 1.645. So what is the rejection region? Rejection region is from negative infinity up to negative 1.645. And the test statistic, negative 3.66, is clearly on the rejection region. Therefore, we reject our null hypothesis. That means we have statistical evidence with 95% probability to conclude that the true mean drying time for formulation 1 is shorter compared to the true mean drying time of formulation 2. Or in other words, you can simply say we have statistical evidence with 95% probability to conclude that the new drying agent is effective. So that conclusion was obtained using the test statistic and critical value approach. And also we have the p-value approach. If you look at the next line, it says the p-value one tail is equal to 0.0001. And if you read the line below the next line, it says p-value two tail. So Microsoft Excel will report both one tail and two tail p-values. And what we need is the one tail p-value, because my alternative is one tail, left-sided. So the correct p-value for this test is not the two-tail p-value, but this given one-tail p-value. Therefore, the correct p-value for this test procedure is 0.00012. So based on the p-value, what's your conclusion? Of course, this p-value is less than alpha, which is 0.05. Therefore, also, we reject our null hypothesis. So once again, we can go for the same interpretation as the interpretation we discussed for the test statistic and critical value approach. Okay, so that's it about the two-sample z-test using Microsoft Excel. Thanks.